So today we are discussing about Cauchy's mean value theorem. So the statement of the mean value theorem: if f of x and g of x are continuous in a comma b, are differentiable in a comma b, and g dash of x is not equal to 0 for any value of x in a comma b, then there exists at least one value c in a comma b such that f dash of c divided by g dash of c is equal to f of b minus f of a divided by g of b minus g of a. So to get these things, we have two conditions. But first we have the two functions. Those are f of x and the g of x. Those are continuous. And the conditions are what? These both are should differentiable and continuous at a comma b. So both the functions should differentiable and continuous at a comma b. So then only this is one condition, and another condition is g dash of x is not equal to 0. So if both conditions are get succeed, then only we get the c value. So let's understand this concept with a problem. So here is the problem, guys. Verify Cauchy's mean value theorem for the function f of x is equal to x square and g of x is equal to x square for the polynomials in 0, 2. So here the given, we write the given, which are f of x is equal to x cube and another function that is g of x is equal to x square, and the values which we have: a is equal to 0, b is equal to 2. So let's first differentiate both the functions. No, first we do the continuous on for both functions. For f of a 0 cube, that is a cube 0 cube is 0. F of b cube, that is 2's cube is equal to 8, and same for the g of x. The g of a is equal to a square, that is 0 square is equal to 0, and g of b square is equal to 2 square is 4. So we got the continuous values for the both the function f of x and g of x. Now we differentiate the f of x and g of x. With respect to x. So after differentiating, the f of x will become f dash of x and x will become 3x square, and same as for g of x. After differentiation, it will become g dash of x is equal to 2x. So now we replace the x with c. F dash of c is equal to 3c square, and g dash of c is equal to 2c. So here clearly we can see that g dash of x is not equal to 0 for any value for value x in 0, 2. Here we can clearly see that g dash of x is not equal to 0. So let's let's prove it by taking the formula, that is, let f dash of c divided by g dash of c is equal to f of b minus f of a divided by g of b minus g of a. So this is the formula. Let's solve this with the values. So now fill the values at 3c square divided by 2c, and the f of b, that means f of b value it is 8 minus 0 divided by 4 minus 0. So these are all the things we have. So after solving this, 8 by 4, 0 0 again, 4 1s are 4 2s are, so we get 3c square divided by 2c is equal to 2, square and c will be on, we take 2 to that side, 3c is equal to 4, and no, c is equal to 4 by 3, we got the value 4 by 3, sorry 3. So now we got that c is equal to 4 by 3, which is belongs to 0 comma 2. Let's state it and such that so if we put the 4 by 3 value in both side, on LHS side and RHS side of the formula, so we get the value 2, which is we get the same value, that is 2. So it's still hence proved, such that we will write f dash of 4 by 3 divided by g dash of 4 by 3 is equal to 2, f of 2 minus f of 0 divided by g dash of 2 minus g of 0. So if you have not understand the logic how it has yet proved or equal, you can check in my previous videos. So there I have solved the how we can prove the LHS and RHS side. So let's state here LHS is equal to RHS. So hence the Cauchy's mean value theorem is proved. So here guys, another problem. So let's solve this problem. So in Cauchy's mean value theorem, for the function f of x is equal to x square and g of x is equal to x raised to 4 in the polynomial 0 comma 1. So here we have the given that two functions, that is f of x is equal to x square and another function is g of x is equal to x raised to 4, and the values a and b is 0 and 1. So let's first verify the continuous theorem for the function f of x and g of x. For f of a is equal to a square, it is 0 square is 0. F of b is equal to 1 square, sorry, b square 1 square is 1. Same for the g of x, it is g of a raised to 4, 0 raised to 4 is 0, g of b raised to 4, 1 raised to 4 is 1. So now differentiate the function. So differentiate f of x, function f of x and g of x with respect to x. After differentiation we get the f dash of x is equal to 2x and g dash of x as 4x cube. So here we clearly see that g dash of x is not equal to 0, so one condition is proved. And now we solve for the another condition. For that we replace x with c and it will become f dash of c is equal to 2c and g dash of c is equal to 4c cube. So now let's take the formula. I'll write it in here. Let's take the formula. It is f dash of c d dash of c is equal to f of b minus f of a divided by g of b minus g of a. So now put the values on what is f dash of c, that is 2c, and what is g dash of c, that is 4c cube, and what is the f of b value, that is 1, f of a value is 0, f of g of b value is 1 and g of a value is 0. So now let's solve. 2 1s are 2, 2s are c cube will gone, become the square. So 1 by 2c square is equal to 1. So this is the 2c square is in the denominator side, so we have to take it to upper side. So we swap the both side of values, that is 2, and then it will become 2c square is equal to 1. Now the c square is equal to 1 by 2, 1 by 2, and the final one, when we take the square to that side, it will become the, and now we take the square to this side, then it will become the root. So root of 1 is 1 only, so we just put, it will become root 2, 1 by root 2. So the value is plus or minus 0.7071. So now we have got the values of c. So let's state it. C is equal to 1 by root 2 is belongs to 0, 1, such that f dash of 1 by root 2 divided by g dash of 1 by root 2 is equal to 1, f of 1 minus f of 0 divided by g of 1 minus g of 0. So this is our answer. So hence it is proved. Hence the Cauchy's mean value theorem is proved. So here is the another problem. Verify Cauchy's mean value theorem for the functions f of x is equal to x square and g of x is equal to x cube in 1, comma. So let's solve this function. So given which we have, that is f of x is equal to x square and g of x is equal to x cube, and the values a is equal to 1 and b is equal to 2. So first we solve the continuous function, that is f of a is equal to a square, sorry, f of a is equal to a square is nothing but 1 square is equal to 1, and f of b is equal to b square, that is 2 square, that is 4, and g of a it is a cube is equal to 1 cube is 1, and g of b is equal to b cube is equal to 2 cube, that is 8. So we get the we got the functions of continuous function of a and b with respect to f and g. So now we have to get the differentiation value of x and g of x. So now after first differentiate f of x and g of x with respect to x. So after differentiation, the functions will be f dash of x, that is 2x, and the g of x will become the g dash of x is equal to 3x square. And now we replace the x with c. F dash of c is equal to 2c, g dash of c is equal to 3c square. Here we clearly can see that the g dash of x is not equal to 0. So the one condition has been proved. So let's solve the another condition. For solving the so to get the another condition solved, we have to solve the equation formula which we have. So let's write it. F dash of c divided by g dash of c is equal to f of b minus f of a divided by g of b minus g of a. So what is our f dash of c value? It is 2c, and g dash of c is 3c square, and f of b value, that is 4, and f of a is 1, and g of b is 8, and g of a is 1. So now square and c will be gone. 2 by 3c is equal to 4 minus 1, that is 3, and 8 minus 1 is 7. So now inverse the functions. So we can cross multiply it like this. So then we get that 3 into 3 is 9c, and 2 7s are 14. So we get the c 9c is equal to 14. So take 9 to that side, and we will get 14 by 9. So we get the c value. So we have got the c value. C is equal to 14 by 9 is belongs to 1 comma 2, such that after putting the c value into the formula, so we will at the both side, RHS and LHS side, we get the value as 3 by 7. Here we get that the answer, that is 3 by 7, that is standard value. So hence it will f dash of 14 by 9 and g dash of 14 by 9 is equal to 3 by 7 is equal to f of 2 minus f of 1 divided by g of 2 minus g of 1. So both the sides will be same. So LHS is equal to RHS. So proved. Hence Cauchy's mean value theorem is proved. That's it, guys. Thank you.